Hello everybody, this is Morgan Freeman. Well, not actually Morgan Freeman, but rather an imitation of reality. In this reality, Morgan Freeman teaches you math. So let's get started. Suppose you have a circle, and you put the numbers 1, 2, 3, all the way up to 1,000 around it in order. You start at 1, then delete the number 1, then 3, then 5, and delete every second number you encounter until there is only one number left. What is the remaining number? If you would like to give the problem a try, pause the video here. And if you just want to listen to my powerful voice as I reveal the answer, that is fine too. Let's start off with a simple case. Suppose we have 4 numbers around a circle. Going in order, we will delete number 1, then 3, and then 2, at which point the number 4 will remain. So, in the simple case, the number 4 is our answer. Now, let's double the numbers on the circle to 8 and see what happens. We'll remove the number 1, then 3, then 5, then 7, then 2, then 6, and then 4, at which point only the number 8 will remain. You might start to recognize a pattern. Let's do one last example by doubling the numbers again to 16 and repeating the process. Going around the circle and deleting every second number we encounter, you can see that we end up with 16. It turns out that for any power of 2, the last digit remaining will always be the largest number. But why is this? Let's go back and analyze the case with 16 numbers. In our first trip around the circle, we delete numbers 1, 3, 5, 7, 9, 11, 13, and 15, at which point we have completed one whole lap of the circle. The next number we will delete is 2, so let's rotate the number so that 2 is at the top of the circle. As you can see, we now have 8 numbers left, and we start by deleting the number at the top of the circle. This is, in fact, the exact same scenario as when we had the numbers 1 through 8 on the circle, in which case we already know the answer must be the last number, so 16. But how can we use this information to solve our problem? Well, first, we want to find some n such that 2 to the n is close to 1,000. Since 2 to the 10 is 1,024, we will use that. So, think about putting the numbers 1 to 1,024 in a circle. Then, starting at 1, we'll delete every second number around the circle until there are precisely 1,000 numbers left. So we'll delete exactly 24 numbers, all of which are odd. To figure out which number is the last one we delete, notice that if we delete one number, we just delete the number 1. If we delete 2 numbers, we delete the numbers 1 and 3. If we delete 3 numbers, we delete the numbers 1, 3, and 5. So if we want to delete n numbers, we have to delete all the odd numbers up to 2 times n minus 1. Therefore, if we want to delete 24 numbers, we must delete all odd numbers up to and including 47. Alright, so back to our circle. Once we've deleted 24 numbers, we will have 1,000 numbers left, but numbered differently than just from 1 to 1,000. Let's rotate our numbers so that the number 49, which is the next number we would have deleted, is at the top. Now, let's also write down the numbers from 1 to 1,000 that correspond to each position. If we interchange these numbers, we get back our original circle with numbers from 1 to 1,000. Now, if we had continued deleting every second number in the first case, we would have ended up with the number 1,024. Since we've lined up our numbers such that the number 1 is at the same position as 49, which would have been the next number we delete, the number that will end up remaining is the number at the same position as 1,024. Counting backwards 24 numbers from 1,000, we get the number 976, which is the number that will remain. So, the answer to what is the remaining number is 976. I hope you've enjoyed the solution to this problem and want to thank you for watching. If you enjoy this type of content, make sure to subscribe to the Quant Quest. I will be back next week with another Brainteaser. After all, a man will do almost anything to keep his mind occupied. See you then.